Hi, and welcome to this talk called Strategic Test-Driven Development. I already introduced myself in the video, so I only say that you can follow me on Twitter. It's the only social network that I really use. The other social network I use to talk about Italian politics, and I suggest you to not follow me on that. You can also read my code name. It's Straz. It's the short version for my surname. It is my code name from the age of 10, I think. So you can call me like that without problem. Probably if you call me by my first name, I will not turn around because just my parents call me like that. So feel free to call me Straz without problem. Before I start, I need also to thank the two guys that you see in the picture. They are two of my friends, developer friends. They are Lorenzo Massacci, it's also one of my colleagues, and Jacopo Romei. That is also speaker at the conference just after my talk, so it's quite funny. And I have to thank them because I start thinking about this talk after I prepared a workshop with them about strategic testing. So we were a bunch of developers talking about testing and about the real meaning of testing, what is hidden under the testing curtain. So let's start. This is a talk about test-driven development, about TDD. So what is test-driven development? Usually the easy answer that everybody should know is that it's just to write test before the code. The point is that, as you can see, Batman is never wrong in his life, okay? So it's not just that. There is something more. It's not just to write the test before the code, but there is something else hidden inside the process. As you can see, the TDD is a software development process, a continuous process. So we start writing a failing test. Then we write the code to pass the test, and if we need it, we can refactor, keeping all the test green and also all the previous tests, in order to ensure us that the code is working correctly. Okay, I just said that there is test before code, but like I said before, there's something else. There's something else hidden inside. It's quite dark in here from this perspective, but I can see some of your faces that it's similar to the guy in the picture. You are asking yourself, what is his point? Where he wants to drive the conversation. I want to focus for a moment on the words of the test-driven development. The first one is, of course, development, but it's okay. There is nothing hidden inside development, but there's something hidden inside driven. How can our development be driven by tests? That's the point. How can tests drive our development process? Let's review for a moment. The point is that we write a test before, then we code, then we refactor. Inside this picture, inside this process, there is a big decision that you have to make every time that you do TDD, and is hidden in plain sight. Probably you are doing that without even realizing it, but you're making a very, very big decision for every cycle of TDD. The decision is the answer to this question. What is the next test to write? Think about it. You start exploring a problem with TDD, and then you start writing the first test. Usually the first test is quite simple, okay? It needs you to start getting warmer with the TDD. Then you start with the second test, the third test. After a while, you will have more than one test in mind, and you have to choose what test to write. in order to help me to decide the next test, I always use this quote from my friend Alberto Brandolini, the creator of Event Storming, and it says that software development is a learning process. Working code is a side effect. This is quite a bold statement, in my opinion. If you talk with developers and you say to them that working code is a side effect, most of the time they will go crazy. But you know, after some years of working, you really understand the deep meaning of that. If you learn the problem, you're actually able to code it. So the first thing that you have to do is to learn about the problem. So, like Alberto says, if that is true, how can we maximize learning? One of the answers is TDD. Because how can we choose the next test? You can choose the test that lets you learn the most about your problem. If in your mind you have more than one test, the next test that you have to write is the test that you think may help you learn the most about the problem. But like I said before, learning about the problem is your goal as a developer. So we can change this sentence and say that we should write the test that let us reach our goal faster as possible. So let's review the process for a moment. So we have to write a test, and we have to choose the test that lets you approach my goal faster in the less number of steps possible. On the other hand, we have to write the code, and then we can refactor. Is that enough? Is just this the decision that we need to make? No, there is another big decision hidden in plain sight. If the first decision was on the red side, on the test side, now we have a decision on the other side, on the green side, on the code itself. Because when you are doing TDD and you have a red test, in order to make the test green, you should write just the code that you need to pass the test. You don't have to over-design, you don't have to overthinking. If it's good enough for that test, stop. Then you can refactor using the test. But this is the most important thing. Choosing the right question and doing just the work that you need to match that question. This is what this is what means to be driven. As you can see, I have a test and I write the code just to solve the test. As you can see, the tests are driving my code. I'm driving my development. They are driving my design. So when you design an algorithm, a piece of code, you have a lot of possibility ahead of you. What is the best option? You can really know before trying. TDD is a way to help you decide. Oh, if you want to put it in a more romantic way, TDD is a goal-oriented decision-making tool based on tests. This is a very, very important way of thinking about TDD, because it's not about testing. It's about decision. Hypothetically, after that you wrote your code, you can delete all the tests and you can write new tests to assure quality. Because in TDD, tests are just a way to design code. Okay, let's go on. There is another important word to analyze, and of course it's test. What is a test in general? How can you define a test? You can also try if you want. It's not easy. You can go on Google, of course, but it's not easy to define what a test really is. You can say that is a piece of code that is testing that your code is working as intended. Okay? Or you can say that is a quality assurance tool for your code. But there is another point of view, a very, very interesting point of view, by Kent Beck. Kent Beck is the creator of TDD, the author of the first test-driven development book. And in an interview, he says that tests are just a form of feedback. Not only that, he says that automatic testing is not always the best form of feedback that you can get from your code. There are some use cases where you may have other form of feedback instead of automatic testing. Now, let us think for a moment. The author of test-driven development not only says that tests are just a form of feedback, but he's also said that you may have other form of feedbacks that, depending on your context, are better than automatic testing. When I read this interview, I think that, something clicked in my mind. This was the turning point of all my reasoning. Because if you think about it and you say that, okay, test is a feedback, we can rewrite the word and we can say that we are not doing TDD. We are doing feedback-driven development, and our feedback is automatic testing. And if you think in that way, if you go down with reasoning, you say that you can rewrite our flow, and we can say define a feedback that lets you approach the goal. Build something small. And this time we have a feedback. Feedback is a more, smoky word. So I can't say that you have to write something that make the feedback green. But you need to build something small. Small enough to use all the feedback to validate your code in the blue area. And I wrote fast feedback because automatic testing is probably the fastest way to have feedback about your code. Because you write the code, your unit testing are running, and then you will immediately see if your code is working as intended or not. But it's just a feedback. It's just a form of feedback. And if we all agree that test is feedback, we can rewrite the sentence from before, and we can say that TDD is a goal-oriented decision-making tool based on feedback. And when at first I get this sentence in my mind, when I start thinking strategically about TDD, I had this reaction. Okay, my mind exploded. Because I felt like I get to an important point to understand how to use TDD, why I was failing with it in some occasion, and so on. So, it was an illumination for me that moment, so I start thinking. Can I abstract the circle of life of TDD, the red green refactor cycle, with something more abstract? Okay, so we have, first you define a goal. Then you build a small outcome. Notice I'm not talking about coding anymore. I wrote outcome. Outcome is a generic word. Then you can use the feedback to keep your outcome and goal in check, exactly as you do with tests. You write the test, but what you're writing is not the test itself, it's your feedback, it's your goal. You use that to code, and then you can refactor, you can validate your code, keeping all the tests green, or keeping all the feedback in check. I didn't change the flow of test-driven development. I just changed the word using more abstract principle. If you want, TDD is instance of this process. Okay, so we said before that TDD is a decision-making tool. Goal-oriented, based on feedback. Okay, so now the point is that I would like to use that kind of decision tool also in other processes, in other kind of decisions, not just about the single piece of code that I need to write every day. How can I do that? The first thing that I have to do is to categorize decisions. This is one standard way to categorize decisions that you make every day in your life, in your company. You have strategic decision, long-term decision that can make years in the making. For example, is we should build this product. You have a fantastic idea for a startup, for example. You should invest your money in that. You should build that software. Or if you want to talk about companies, we should merge with this other company. We should fire these people. These are strategic decisions, a long-term vision. Then you have tactic decision. Tactic decisions are mid-term decisions, and they put your strategy into action. Okay, for a software, for example, and we will see that in a moment, a tactic decision is, for example, software architecture. We have a strategic decision that is the software itself, the life of the software itself. When we decided that we need to put the software into development, we need to create a software architecture that helps us reaching that strategy decision. Then you have operational decision. You can also call them field operational decision because of the military ground of these words. But operational decisions are just the decision that you make every day. You are at your desk and you may have to make decisions. You may understand that TDD is a tool to make operational decisions. Now I'm talking about the real TDD, red, green refactor. Because it's a thing that you can do every day at your desk or with your companion if you're doing pair programming to build the best code possible to solve that problem. The question now is, how can I do that? How can I use that? Also, to attack strategic and tactic decisions. It's possible to do that? I think yes. And I will tell you 3 kinds of decisions that you can actually solve with the same pattern. Okay? So, the first one. The first tactic decision that I want to show you is to choose the next feature. You have a backlog. You have to choose what feature to implement next. Hypothetically, if you are working with WIP limited to 1, okay, or the next bunch of feature, okay. This is a tactic decision because you are not making it daily, and because your decision should be useful to arrive to the strategic goal. So how can we do that? Okay, we saw before that to use the TDD mindset for other kind of decision, we need 3 things. We need a goal, or a goal that we can split or can we control. We need a small outcome, that in this case is the feature itself, okay? It's a user story if you want. And then we need feedback to check if our outcome match with our goal. We need these 3 elements. So what are these 3 elements where we are talking about choosing the next feature? Okay, a tool that I use with my teams or when I am a consultant for other clients is impact mapping to actually build, define a backlog, okay? Impact mapping works in this way. You start from the left and you define a goal. This is a mid-term goal, okay? Let's hypothesize 6 months. In 6 months, we want to grow our mobile advertising revenues. This is the mid-term vision of the company about our product. Then you ask yourself, what are the users, the actors that can help us to achieve that goal? In this case, you have super fans with mobile devices, or concert organizers, or artist agent and promoters. Probably we are talking about an app to organize concert, okay, and selling tickets, for example. Okay, then you are asking yourself another thing. For any of these actors, how can they impact our goal? What we can do for them in order to make them help us in our goal? And so you have the impact column. For example, we can say that, analyzing just the first one, we can say that super fans with mobile devices, if they will come more, we believe that if they will come more frequently, they will help us have more mobile advertising. Or we can also say, we believe that if the super fan with mobile devices will stay longer on the application, we will sell more mobile advertising, and so on. All the impacts have something in common. You can match, you can look at it. There is one thing, two things actually, sorry, that they have in common. The first thing is they are all assumptions. I said, we believe that. We can't know for sure. And how do you can turn assumption in a fact, you may guess it, with feedbacks. So, there is another thing in common that all impacts should have. They are all measurable. You can build a metric out of it. For example, if I say, come back more frequently, I can count the visit of the super fan with mobile app. If I say stay longer, I can measure the time of each visit. If I say view more ads, I can count how many ads they are viewing. So, we have our goal and we have our feedback. Because in the impact itself, we have the feedback, that is the metric. Is how that metric is helping us achieving our goal. And then we have also the small outcome, because from the impact, we can build deliverable, epic user stories, something like that. So now that we have the three elements, goal, small outcome, and feedback, oh, it's broken. We can change the graph and use the TDD mindset to choosing the next feature. We can choose the impact that we believe that we help the most to reach the goal. Remember, I use the word believe because it's an assumption. I don't know that. Then I build a small deliverable, and then I use the metrics inside the impact to validate my assumption. If, for example, I create a user story that comes from an impact about staying longer, I can measure if the user are actually staying longer. If yes, I can also measure if they are helping my goal. Are we having more mobile advertising? It could be true or it could be false. In either case, I have more information and I can decide what to do next with the next impact, with the next deliverable. And we can go on in this way. Exactly like TDD is an iterative process based on feedback to reach a goal. Another important tactic decision is software architecture, like I said before. What I mean with software architecture: microservices, monolithic, dynamic language, typed language, frameworks, tools, continuous integration, all this stuff I mean with software architecture. My idea is that we can build a software architecture with the same process of TDD. I'm not saying that we can exactly TDD the software architecture, but we can do something similar. But to do that, we need a goal, a feedback loop, and a small deliverable, like before. So the first question is, what is the goal of software architecture? This is a tricky question, because most of the time, developers and architects believe that they should support your functional requirements. You have a bunch of user stories to make, and you decide your architecture based on what the software should do. But there is something hidden inside software architecture that not so much people talks about. You may find some information about the topic that I'm going to explain in a book called Building Evolutionary Architecture, just to let you know that this stuff is very, very related to software architecture. And they are non-functional requirements. Non-functional requirements are opposed, if you want, to functional requirement because they judge the operation of the system rather than the behavior. Functional requirement, or if you want user stories or Jira ticket, whatever you want, they explain what a software should do. A non-functional requirement tell us how a software should be, in general, not about a specific feature. This that you can see here is a non-comprehensive list of non-functional requirements. You can find it on that book from before, Building Evolutionary Architecture, or on Wikipedia. This is just the first 30 or 50 that I tried to put on a slide. They have something in common. Almost every word finish with ility. So they are also called the illities of your software. And we have something like performances, configurability, stability, securability, predictability, recoverability, and so on. So the goal for your architecture is to, of course, to support your functional requirement. But as an architect, you also have to choose a subset, a small subset of this non-functional requirement. And you have to be sure that your architecture is supporting also non-functional requirement. So now we have a goal. Our architecture should support non-functional requirement. Okay, we have a goal. What is the feedback then? The feedback for non-functional requirements are called fitness functions. A fitness function could be automated or not, but it's just a way to assert that our architecture is supporting a specific non-functional requirement. Some of them are completely configurable. For example, performances. You can create an end-to-end test for your application, and you can measure performances. You can do a stress test. You can do a lot of things to test non-functional requirement. For example, you have fault tolerance or resilience as a non-functional requirement. You can build some chaos engineering tool that try to put down your machine in production. If they are okay, you are resilient. So, goal, we have a goal, we have a feedback. We need an execution, a small outcome. What is a small outcome for architecture? Working skeleton is a way to build software architecture that is based on tiny implementation of the system that perform a small end-to-end implementation. You can change the internal pieces of the architecture. For example, you can swap a memory database with a SQL database or a NoSQL database, but the parts of it are already linked. You are working from day one on a real architecture. In this way, the architecture and the functionality can evolve in parallel. So, you know the drill. We have a goal, we have a small outcome, and we have a feedback. So we define a set of a non-functional requirement to check, and we write a fitness function. We build a walking skeleton of our application, and our tests are green, if you want. Then, during the blue phase, we start to building features, and we evolve the architecture with them, keeping all the non-functional requirements in check with the tests, with fitness functions. Then, after a while, the non-functional requirements will change during time. For example, at first you don't need scalability or performance if you're a startup. After a while, if you're lucky, you need scalability. So when a new functional requirement emerges, you are again in the red phase. You write new fitness function, the fitness function will fail, and then you evolve your walking skeleton. And then you start adding features, keeping your architecture in check. Now with the last decision is the most strategic one. We should build this software. You are in a bar with a couple of friends, and one of them has a fantastic idea for a startup. We will conquer the Silicon Valley with this idea. I don't know, it happens to me most of my dinner because I'm the only programmer with my friends, so they believe that I can make everything. But how can we answer that? We have an idea, and we should build or not this software. We should invest our time, our money in that. Like before, goal, feedback, small outcome. The goal is obviously to build the software. The outcome could be an MVP in this case, so we just need the feedback. What is the feedback that we need? Generally, it's what is called user research. It's a very complex argument, very complex topic. So it's about, talking with your user, market research, investigating personas, and so on. It's talking with actual people, the feedback. So, you have now another loop. You have to define your idea. You have to build a small outcome. It could be at first a business model canvas, then can be a landing page, then can be a small prototype. You can do 4 or 5 loops of TDD without even coding anything. Then you have user feedback to validate your idea. We always have the same loop, but in this case, the feedback loop is usually longer. Your goal is to make the feedback loop as shorter as possible, exactly as in TDD. You can't automate user feedback, at least at the first times, but your purpose is to shorten the feedback loop. So as you can see, we started with strategic decision. We should build our software, and we do that with TDD. Then we go to tactical, with software architecture and backlog filling, if you want. And then you go with real TDD, all with the same loop life cycle: goal, small outcome, and feedback. To close my talk, I would like to share with you how came up with this idea. The point is that when you use a tool, at first you should learn the rules of the tool. Red, green refactor, red, green refactor. Strictly follow the rules. After a while, you should find the principles behind the tool. Every rule set ever made in the universe should be based on principles. So when you get that principle, and in my idea is the goal, execution, feedback loop, you can explore interrelationship between tools. The last phase is what helps you to find a new way, and you can create also your own rule set after a while. Thank you very much. It's been a pleasure.